Hello friends, in this video, let's see training hetero associative memory network. And this hetero associative memory network is a network in which um, the training input and the target output are different, unlike the auto associative memory network. Uh, let's go to the question. And here we have given four inputs along with their targets, and we have asked to test the network using the input as testing input. Fine. So as in auto-associative memory network, we have to find the weight value initially. So for heteroassociative memory network, for calculation of weight, we have two ways. One is using Hebb rule, and the other is outer product rule. Hebb rule, means we have used in perceptron, right? Finding new weight using volt weight plus learning rate and target value. So that manner is called Hebb rule, and the outer product rule is we have to transpose our input vector and has to multiply with the target vector. So if particularly they ask in question to calculate the weight using Hebb rule or using auto product rule, then you go according to that question. If not mentioned, it is easy to proceed with outer product rule. Okay, so here they didn't mention any particular method to calculate the weight. So I am proceeding with outer product rule. So now let's compute the weight first. So for the first input, the vector input vector is 1 0 0 0. If we transpose it, see 1 0 0 0. So and the target t they have given 0 1 0 1. Now it's time to find the weight. H transpose into t. So 1 0 0 transpose of s and 0 1. If we multiply, we will be getting 0 1 0 0 0 0 0 0, right? Yes. And let this be W1. And let's proceed to second vector. The vector given is 1 1 0 0, right? Yes, 1 1 0 0. And the transpose is 0 1. So we get W2, that is 1 1 0 0, and the target is 0 1. So if you multiply, you'll be getting 0 1 0 1 0 0 0 0. Good. And find W3. So okay, S1, S2, S3, that is 0 0 0 1. See 0 0 0 1. And target for this is 1 0. So the W3 is 0 0 0 1 multiplied with 1 0. That is 0 0 0 0 0 0 1 0 is our W3. And find W4. S4 is 0 0 1 1 0 0 1 1, and the target for this is 1 0. So find W4, that is 0, 0, 1, 1 multiplied with 1, 0. We'll get 0, 0, 0, 0, 1, 0, 1, 0. So to find the W, we have to add all obtained weights. W is equal to W1 plus W2 plus W3 plus W4, which means W1, 0, 1 and all zeros. So 0, 1, 0, 0, 0, 0, 0, 0 is our W1, and W2, 0, 1, 0, 1, 0, 0, 0, 0, 0, 0, 0, 0, and W3, all zeros, 1, 0. So 0, 0, 0, 0, 1, 0, 0, 1, 0. And W4, 0, 0, 0, 0, 1, 0, 1, 0. 0, 0, 0, 0, 1, 0, 1, 0. So if we sum it up, we'll get 0 and 1 plus 1, 2, and 0 and 1, and 1, 0, 2, 0. So this is our weight. So W is 0, 2, 0, 1, 1, 0, 2, 0. Simple. It's simple. Use the auto product rule for a calculation of weight value. If we go to the question, they have asked us to test the performance, giving the input as testing input. So let's take our first input as our test input. So we are going to test the network. So let's take our S1 as test input. So if we take as test input, it becomes S1 bar. So now find net input value. The formula is sigma xi wij. So it means I is equal to 1, 2, n. So if y in 1 is equal to x1 w11 and plus x2 w21 plus x3 w31 plus x4 w41. So our x1 is 1 and w11 is this into 0 plus our x2 is 0 and w21 is this. x3 is 0, w31 is 1 plus x4 is 0 and w41 is 2. So if we compute, we get 0. And calculate y in 2. I1. So y in 2 is sigma I is equal to 1 xi w I2. So we'll get x1 w12 plus x2 w22 plus x3 w33 plus x4 w44. Sorry, exchange, sorry. 3 to 4 2. So x1 is 1 into 1 2 is 2 plus x2 0 into and 2 2 is 1 and x3, my god, sorry again, plus 0 into x3 2 is 0 plus x4 0 and w42 is 0. We will get 2 here. Now find y1. We have done it right. After calculating that input, we will apply the correspondent activation function and get the input value. So here we are having 0 and 1, so we'll be applying binary activation function. So it's 0. So f of y in 1, f of 0, that is 0, and 2 greater than 0, right? So we'll get y2 is equal to 1. That means our output is 0, 1, which is this 0, 1 is the target of this 0, 1 is the target of the first input. So we obtain correct response. So correct response for first input pattern. Good pattern. Now let's test with the second input. So what's happening? The second input is fine. So our second input is forgot again. Sorry. Which is the second input? 1100. Yes. So what S2? Since we are taking our S2 as first input, let me keep bar. First showing the difference. 1100. Now compute the net input. So y in 1 and our weight is 0 2 0 1 1 0 and 2 0. Yes. So now compute y in 1. So 1 into 0, 0 plus 1 into 0, 0 plus 0 into 1, 0 plus 0 into 2, 0, that is equal to 0. And compute y into 1 into 2, 2 plus 1 into 1, 1 plus 0 into 0, 0 plus 0 into 0, 0. So we obtain 3, which means our y1 is equal to 0 and y2 is equal to 1 after applying the activation function. So our final output is 0, 1. Let's check the second input vector having the target as 0, 1. So if you see here, it's 2. So our response is correct. Correct response for second input pattern. Now let's check for third input. By testing with third input vector. Third input vector is 0, 0, 0, 1 if I'm not wrong. And compute y in 1. So 0 into 0, 0 plus 0 into 0, 0 plus 0 into 1, 0 plus 1 into 2, 2, 2, and compute y into, so 0 into 2, 0 plus 0 into 1, 0 plus, and 0 into 0, 0 plus 1 into 0, 0, 0. After applying activation function, we will get y1 is 2, right, greater than 0, so we'll get 1, and y2 is 0. So our final output is 1, 0. Check the target matrix of third one as 1, 0. So correct response is obtained for the third input vector. Now let's check with fourth input vector. So 0, 0, 1, right? Compute y in 1, y in 1, so 0 into 0, 0 plus 0 into 0, 0 plus 1 into 1, 1 plus 1 into 2, 2. We'll get 3. Now compute y into, so 0 into 2, 0 plus 0 into 1, 0 plus 1 into 0, 0 plus, and 1 into 0, 0. Means 0. After applying activation function, our y1 is 1 because it is greater than 0, and y2 is 0. Our final output is 1, 0. So check the target of fourth vector. Yes, it's 1, 0. So correct response is obtained for the fourth input pattern. So this is how the hetero-associative training network is performed. So thank you.